Okay, so here's our first bonus video. Um, in this case, we're going to kind of be looking more at those fractions, but now we're going to be looking at fractions that do not have like denominators. So kind of just review, this should be review from really elementary school, is what do we do if we have fractions that have unlike denominators? Well, we will multiply each term by the other denominator. So times 4 and times 4, and times 3 and times 3, and we get 8 over 12 plus 3 over 12, and we get 11 over 12. So that's something that hopefully we know how to do very, very well. Now, when we get to trig, it's a little bit trickier, but it all starts working out. So in this case, I'm going to do times sine theta and times sine theta. And on my right side, we'll do times cosine theta and times cosine theta. And so that gives us in the numerator sine theta over sine theta cosine theta plus cosine theta over sine theta cosine theta. And then from there we just have sine theta plus cosine theta. When you add those, nothing happens. It's just sine theta plus cosine theta divided by sine theta cosine theta. Now, I want you to be very careful about this. This does not simplify any further. This numerator is not a trig identity, right? The trig identity is sine squared theta plus cosine squared theta equals 1. We need to have that squared in there. In this case, we don't have any squared, so we don't have a trig identity, okay? So because we're missing the squared, it's just sine theta plus cosine theta. That's okay. Similarly, we cannot cancel out a sine theta. I see a lot of students who try to say, oh, let's cancel out the sines, let's cancel out the cosines, and I get 1. That does not work. Okay, you cannot cancel out terms, and that's because of this plus sign. This plus symbol is kind of a separator. Whenever you see that plus symbol, the only way to cancel is by factoring. There is kind of a shortcut, right? Like if you had, say something like x squared plus 2x over 4x, right? You can factor out an x in the numerator, but if you see, hey, wait, I have an x everywhere, right? I have an x in my first term, in my second term, and in the denominator. Yes, I can cancel out one of them. So I'd get x plus 2 over 4. But that's because it was everywhere. In this case, sine is not everywhere. We're missing the sine in this second part. So because of that, we're done. Okay, this is the right answer. We're fine with it, and we're done. So just be very careful about that. Whenever you see something with a plus symbol, you cannot just cancel out unless it's everywhere. Okay. So moving on to C. All right. C is a little bit trickier. Let's zoom in here a little bit. So on C, we want to multiply. I like to kind of write these in parentheses because I know we're going to be multiplying. So I want to multiply 1 plus cosine theta to the first term because that was the other denominator, and 1 plus cosine theta. And then I want to multiply 1 minus cosine theta and 1 minus cosine theta. So now we end up with our first term is 1 plus cosine theta divided by 1 plus cosine theta times 1 minus cosine theta. Yes, you can FOIL this, but don't. And I'm going to talk about that in a second. Okay. The reason we're not going to FOIL it is whenever we're simplifying rational expressions, rational meaning kind of fractions, right? P over Q. Whenever we're simplifying these fractions, a big hint, maybe your math 3 teacher told you this, maybe not, but a big hint is to always simplify the numerator. So you want to simplify, FOIL, whatever you can to the numerator, but you want to leave the denominator alone or leave it factored. So we're going to leave the denominator factored as much as we can, and then we can see what cancels out. But this is kind of a big hint for you, okay? Whenever you see these fractions, you're trying to simplify fractions, always try to simplify your numerator, but then leave your denominator factored. So in this case, right, we're going to, for our numerator, simplify it by adding, okay? So we're going to look at what are our like terms. Well, the numbers 1 plus 1 gives 2. And then we have plus cosine theta minus cosine theta. Those are going to cancel out. we have 2 divided by, and then we're going to just leave the denominator as is. The reason you don't want to FOIL it is if you FOILed it out, you're just going to simplify, want to refactor it. That doesn't really make any sense. It's already factored for us. So we're done. So 2 over 1 plus cosine theta times 1 minus cosine theta. All right, that one's a little bit trickier. All right, next one. All right, we have tangent theta divided by secant squared theta over tangent theta. Okay. In this case, right, I see a fraction. So if I'm trying to add a fraction, we need like denominators. So I'm going to put tangent theta divided by 1. So times tangent theta and times tangent theta. So this gives us tangent theta times itself becomes tangent squared theta over tangent theta. And remember, whenever we see these squareds, I was saying you want to start thinking about those Pythagorean identities as much as you can. So first, I'm going to just kind of combine it into one fraction. So tangent squared theta minus secant squared theta all over tangent theta. Again, the tangents do not cancel. Please don't cancel them, and that's because this minus, that's the same as the plus, right? So I would need to have a tangent everywhere. This is kind of like first term, second term, third term. It's not everywhere, so I can't simplify it, okay? But what we can do is we can apply those Pythagorean identities. Tangent and secant work really well with each other, right? We had that Pythagorean theory identity, right? If we go back up, we actually have 2 of them with tangent and secant that could work here, and we can choose either one. So we can replace tangent theta, right? We can rewrite it as secant squared theta minus 1, or we can replace secant squared theta and rewrite it as 1 plus tangent. Either way works, okay? I'm going to choose to replace tangent theta just because it came first, might be a little bit easier. So we're going to, instead of writing tangent squared, we're going to write secant squared minus 1. Okay, so coming back down here, right, instead of writing tangent squared theta, this first term, we're going to write secant squared theta minus 1. I'm going to put in parentheses just because I'm replacing it. Whenever I replace things, I like to add a parentheses just to make sure I'm not missing any positive or negative signs. Okay. And then now, secant squared theta, looking at like simplifying, combining like terms, right? Secant squared theta minus secant squared theta, that's going to cancel out. And we're left with negative 1 divided by tangent theta. Now, that's almost the answer, but not quite. Whenever we have 1 over tangent, that can be simplified to cotangent theta. Don't forget about the negative sign. All right? I think we have 2 more examples. So next, tangent theta over cotangent theta plus 1. Right? I'm going to just kind of lollipop that times cotangent theta times cotangent theta. So we get tangent theta plus cotangent theta over cotangent theta. And this one's a little bit tricky because what's going to happen is we're going to say, hey, wait, I don't have any Pythagorean identities. And I don't, so I can't do, there's no squareds, right? So what can I do? Well, we can kind of say, okay, what is tangent theta? Tangent theta is sine theta over cosine theta plus cotangent is cosine theta over sine theta, and that's all over cotangent theta. Now, the reason I'm not writing cotangent theta as cosine over sine is, remember, what did I say? Let's first work on simplifying the numerator, but leaving the denominator factored or alone. So we're going to simplify the numerator, but leave that denominator alone. So in our numerator, I'm going to write times sine theta times sine theta because we're trying to combine like terms, so we can factor this, and times cosine theta, get a like denominator. Okay, so this is going to give us, in the numerator here, sine times sine becomes sine squared theta over sine theta cosine theta. And then plus cosine times cosine becomes cosine squared theta all over sine theta cosine theta. Now, a lot of students will just write this, and then they'll keep going, they'll keep going, they'll keep going. They'll totally never, ever add back the cotangent. So please, please, please don't be one of those people. Please always just rewrite everything that you have all over cotangent theta. All right, now, I know this is kind of running out of room here. we're going to add the sine squared theta plus the cosine squared theta, right? Because we have these like denominators here. And I'm going to kind of skip a step a little bit because I could write sine squared theta plus cosine squared theta. But remember, that's our most basic trig identity. That's the one we always want to remember. That's like the main one. Whenever you see that one, it's great because that one just becomes 1, right? Sine squared theta plus cosine squared theta, that becomes 1. So this is going to become 1 over sine theta, cosine theta, all over cotangent theta. Now, I said simplify the numerator as much as you can, leave the denominator alone. In this case, though, this definitely doesn't look nice. So I think that we need to, at this point now, say, okay, well, what can we do about cotangent theta? So we have, I'm going to write over here, 1 over sine theta cosine theta over, now for cotangent theta, what can we do? We can write that as cosine theta over sine theta. And what do we do when we have a fraction and a fraction? We multiply by the reciprocal. This one is definitely kind of why this is a bonus section. So we're going to multiply by the reciprocal. The reciprocal here is sine theta over cosine theta. What happens is the sines cancel out to 1. So we get 1 over cosine times itself becomes cosine squared. And then 1 over cosine is secant, but we have that squared, so we get secant squared of theta. This one was definitely challenging. It was a lot of work. You know, there is another way to do this one that I like a little bit better that's a lot less work. And that would be actually to just try to simplify that first. You know, write sine over cosine on top and cosine over sine on bottom and multiply by the reciprocal. It'll actually go a lot faster. You'll end up with tangent squared, and then tangent squared plus 1 gives you secant. So if you want to try that, you can. But anyways, that's kind of how we do that. All right. Lastly is f. Okay, f is a lot easier than the one we just did. So on f, right, we multiply cosine times sine theta times sine theta, sine theta times cosine theta, and times cosine theta. And so we end up with sine theta over sine theta cosine theta plus cosine theta over sine theta cosine theta. And we, like I said, we're going to always add our numerator first, leave our denominator factored as long as we can. So we get sine theta plus cosine theta all over sine theta cosine theta, and that's it. We cannot simplify that any further, right? There are no trig identities here because we can't do a squared with it, right? If we change it to cosecant, secant, it doesn't help us, and we cannot simplify because of that plus sign, right? It was having different terms. So that's it. All right. Homework on this is going to be these first 2 questions are going to have answers. They're going to be kind of similar. And then these guys are verifying the identity. So whenever we're verifying an identity, what you're going to do is you're just going to kind of write a long line down the middle. And you're going to work on the left side. And you're just going to continue to rewrite the right side. So I'll do number 3 with this. So we're going to have 1 plus cosine squared theta. We're always going to just be rewriting that. And then on the left side, we're going to try to figure out, hey, how can we simplify this a little bit more? So in this case, actually, this is something where if you watch the next bonus video, it'll actually help us out a little bit on this one. Because what we can do is we can do this trick where I'll explain it more in the next video. But anytime we have a plus symbol on top in the numerator, we can break it up. So we can write this as 1 over secant squared theta plus secant squared theta over secant squared theta. So what we're doing is we're basically just taking the numerator and we're breaking it up. We're splitting it. You can only do that with the numerator. You can never ever split the denominator. Okay, say that one more time. You can only ever split the numerator. You can never split the denominator. Okay, what is 1 over secant? 1 over secant we call cosine, but it's going to be cosine squared theta. And plus secant over itself is 1. Okay, we're not quite there. We're pretty much there. Now we just need to reorder those, right? The commutative property. So 1 plus cosine squared theta equals 1 plus cosine squared theta. You can always do that, just rewriting it, and put a check mark. So when you're verifying the identity, it's kind of like they gave you the answer on the right side. They're saying, hey, take this left side and make it look like the right side. Okay. So same thing here. Take the left side, make it look like the right side. Just put a line. Just keep rewriting 1 over cosine theta, sine theta. Right? Put it like an equal sign. And you're going to just keep rewriting it until the left side looks like it. Okay? So those bottom 4 are not going to have answers. You're going to have to, or actually I think it's 8. Those bottom 6 are not going to have answers. You have to make them look like what the right side looks like. Actually, 7 and 8 don't even have a right side, so let's get rid of 7 and 8. I think that's why I said that. So we're only going to worry about these ones, and there's that. Okay, there's one more bonus video if you want to do it. If you're good with this one, you can do just this one, or you can do them both.